we are having a numerical example. We expect the numerical examples also in the physical chemistry. And one such here is, for a cubic crystal, phase diagonal is 3.5 angstroms and its phase length is to be calculated. For most of the times, you have to rely upon the formulae and the relations in solving such problems, because that saves a lot of time in the examination. For the face-centered cubic unit cell, the face diagonal and the face length means the edge length, are related as the face diagonal is equal to root 2 times of A, root 2 times of edge length. This is quite familiar to you in the theory part, where you worked it as in the face-centered cubic unit cell, when we are taking the face diagonal here, and this face diagonal is nothing but the root 2 times of the face length. Therefore, the relation becomes with the edge length, it is equal to face diagonal divided by root 2, and this gives the value 3.5 divided by 1.4, roundabout I am taking, and that becomes 2.5, roughly approximated value 2.5. Close to it is the 2.475 angstroms. So that is how the calculation works out. Option number B or option B is correct. In the next, sometimes we are expected to go for such calculations also. The lead sulfide is isostructural with NaCl. The shortest distance between the Pb plus 2 and S minus 2 ions is given. With the help of this shortest distance, we are expected to give the volume of the unit cell. So there, two things are to be taken care of. One, what is isostructural pattern and what is the structure of NaCl. Isostructural means it is the two different crystalline samples having the same arrangement of the particles in the crystal lattice are called as isostructurals. So the structure wise, PbS and NaCl have the same pattern. And what about the NaCl structure? For the NaCl structure, which is a face-centered type, we have the edge carrying alternate arrangements of Na plus and Cl minus, and that we put this way. At the center, if we have the smaller positive ion Na plus, on either sides it will be the larger Cl minus, and the center of these spheres, the extreme spheres Cl minus, that becomes an edge. So if this is the edge for NaCl, the same will be the edge for PbS also. The supplied information is the shortest distance between the Pb plus 2 and S minus 2. That means the positive and negative ions. It is the positive ion at the center and the negative ion on either sides. The shortest distance, we get it here. And this shortest distance is 297 picometer in lead sulfide between the Pb plus 2 and S minus 2. And with this distance, can we get the edge? Very simple. It is half of the edge length because it is only the two radii making up 297 picometer, and the entire edge, if it is to be taken, we just have to double this value, 297 picometer. And I don't want to do it with precision because for me the time is important and I look at the options. Options have bigger margin of difference. Therefore, with the approximation, I continue. 397 is approximated to 300 picometer, and I know 1 picometer equal to 10 raised to minus 10 centimeter, and that is the unit in which the answer has to be given. Therefore, it is 300 into 10 raised to minus 10 centimeter, or I can put it as 3 into 10 raised to minus 8 centimeter. This is half. And about the entire edge, I double it. Therefore, edge, that is A, equal to 6 into 10 raised to minus 8 centimeter. It is the edge. And what is the volume? A cube will be the volume, and this is equal to 6 into 10 raised to minus 8 whole raised to 3. And I know 6 raised to 3 is 216. So it is 216 into 10 raised to minus 24 centimeter cube. The closest of 216 is number 1, 209.6 into 10 raised to minus 24 centimeter cube. Therefore, I go for option A, 209 into 209.6 into 10 raised to minus 24 centimeter cube. That way. See here how these are working out. They require the time which is just enough, about 40 to 50 seconds. Like half of the edge length, approximated value, double it, edge length, then go for the volume. Immediately it will be giving the answer in simple calculations. Are you clear?